Constraint residue accumulation model describes a structural condition in which past failures remain inside a system as persistent rules. A system fails, a deviation appears, an output behaves unexpectedly, a workflow produces an exception, a policy misses an edge case, a model generates something unwanted. The system responds by adding a restriction. At first, the restriction may work. It may block the visible failure. It may reduce risk. It may make the system appear more controlled. But suppression is not source-level resolution. The central distinction is simple. A constraint added is not a source condition resolved. A rule can prevent a repeated deviation while leaving the deeper reference layer, process design, responsibility structure, semantic field, or operating condition unchanged. When this happens repeatedly, the system begins to accumulate residue. Constraint residue is the persistent trace left when a prior failure is converted into a standing control element. The present control layer becomes current design plus past failure residue. It is no longer only an instruction, policy, interface, prompt, checklist, or governance layer. It is also a sedimented record of what failed before. A deviation appears, a local restriction is added, the visible behavior is partially suppressed. The original failure context fades, the restriction remains. Later controls interact with it, new deviations appear, more restrictions are added, residue accumulates. Over time, the system may appear more governed because more rules exist, but rule density is not structural resolution. A dense control layer may contain prompt fragments, safety warnings, review gates, policy clauses, exception lists, routing rules, moderation categories, dashboard fields, and checklist items that preserve pieces of past instability. This can help the system survive. It can also make the system more brittle. The system becomes harder to interpret because every present instruction carries invisible history. A rule may remain after the failure that produced it is forgotten. A warning may still operate after its original context is gone. This is context decay. Context decay occurs when the reason for a constraint fades while the constraint remains active. When many constraints accumulate, they begin to interact. One prohibition narrows the field, another exception modifies it, another review gate slows it, another policy clause shifts responsibility, another prompt rule redirects output. The system becomes not only controlled, but layered with residue. This is interaction load. Interaction load means the burden produced when accumulated constraints overlap, conflict, multiply, or require interpretation. In AI-mediated systems, this appears as prompt sedimentation. The prompt is no longer only a task instruction, it becomes a stack of prior corrections, safety patches, format rules, prohibitions, and edge case warnings. In institutions, this appears as policy accretion. An incident leads to a policy addition. A new exception leads to a checklist. A new risk leads to another approval gate. The workflow thickens. The source condition may remain unresolved. Constraint residue accumulation should not be applied to every rule, policy, or safety design. Some constraints are necessary, current, coherent, and derived from the system architecture itself. The model applies when control elements persist as traces of prior failure, especially when the source condition has not been resolved or when the original context has decayed. The analytic question is what prior failure this rule preserves, whether that failure remains visible, and what happens when residues accumulate. Naming declaration. The constraint residue accumulation model originates within meta-writing ecology as a structural model for describing how prior failures, deviations, exceptions, or undesirable outputs become embedded as persistent constraints within instruction, governance, interface, workflow, or policy layers. Here, constraint does not mean only a technical rule or prompt instruction. It may include prohibitions, exceptions, warnings, review gates, compliance clauses, labels, dashboard fields, tool use restrictions, moderation categories, or other control elements. Residue means the persistent trace left when a prior failure is converted into a standing control rule. It does not mean the rule is invalid. It means the rule carries historical failure memory. Accumulation means repeated layering. This model is not derived from prompt engineering, AI safety taxonomies, compliance theory, organizational learning, technical debt literature, software maintenance theory, policy implementation studies, or conventional governance control frameworks. Those fields may intersect with it, but they do not define its bloodline.